A jack and a seesaw.
For centuries, us human beings have been using our superior brains to invent systems that give us a mechanical advantage to make up for our lack of strength. The manual hoist chain, or block and tackle, is our first example of mechanical advantage. This is a 5-ton chain block, meaning it can lift 5,000 kilograms. It has a very strong hook attached to a thick chain, capable of lifting 5 tons. A much thinner chain is used by a human to pull on, in order to lift the load up. To operate the chain block we need a strong support, like a tree or a beam to hang. In the diagram the person pulls the thin chain, that's effort. The hook lifting the mass is force, multiplied. The thin chain is 5 meters long. We mark one link with red paint and position a ruler to measure the distance traveled. We pull the chain to move around once. The main source of electricity used by most people are batteries. Here we have a selection of cells and batteries. The main source of electricity used by most people are batteries. Here we have a selection of cells and batteries. Even though we call these batteries, they are actually cells. A battery consists of several cells. Larger cells don't give more power, they just last longer. Cells can be connected to each other in different ways. Series and parallel. These two cells are connected in series. These two cells are connected in parallel. This is a car battery. It has a positive pole and a negative pole. It has 6 cells of 2 volts each inside the casing. 6 cells of 2 volts each means this battery is 12 volts strong. This is a 9-volt battery. It has a number of cells inside connected in series. In the next section we will look at fruit and vegetables as a source of electricity. Voltaic found out that 2 metals and a conducting liquid can give out a voltage. Acids are conducting liquids and they are sour. What can you think of that contains an acid? What about a lemon? We will use a piece of copper wire, a piece of iron wire, and a lemon. Push the 2 pieces of wire into the lemon as shown. Then connect the wires to a multimeter. The lemon gives a reading of 0.38 volts. This lemon is only a single cell. Next we will make a battery by connecting several lemons in series. Use 4 lemons to bring the voltage up 3.6 for a cell phone for example. The reading is now 2.8 volts. It is closer to what we need. But, even this may have a proper reading but it does not give enough current to charge a cell phone. Some vegetables can also make some electricity. Let's look at a few potatoes next. Here we have connected 4 potatoes in series to make a battery. The reading on the meter this time is 3.55 volts. In the next exercise we will look at salt water. Let's try a salt water solution. This will give us an alkaline battery. Fill 4 beakers with salt water and connect it as shown here. How can we change the voltage? Adding more salt will make a stronger solution. Add some more salt to each beaker and stir until it is dissolved. Then check the reading. Even though we get decent voltage readings, the current pushed out is not reliable or strong enough. The voltage is affected by many factors. In this section you will be introduced to electrical circuits. From the basic circuit and components to circuit diagrams and component symbols. Basic circuit components are cells, connectors, switches, resistors and lamps. You will learn simple circuit diagrams, the conventions used and the various component symbols. A circuit needs three things: a source of energy, a user of that energy, and a carrier for the energy. Here is an example of the most simple circuit. It consists of two SiSi torch cells connected in series, conducting wires, a light bulb, and a switch. Here a multimeter is connected to it to measure the voltage. The reading on the multimeter is 3.38 volts. There is no current because the switch is off. Next, see what happens when we switch it on. The lamp filament glows, but not very bright. Look at the volt reading now, it went down to 2.75. What happened? Where did the other power go to? The first reading was over 3 volts because only the cells gave a resistance. When the current flows after switching it on, work is done and all the other components give resistance. Now, if you switch the circuit off again, the multimeter reads 3 volts again. This is known as the working voltage of a battery. The following basic minimum circuit diagram we introduce you to the symbols used for different components. We start with battery, which consists of two cells, shown by a long thin line and a short fat line. There are two of them indicating two cells in series. Next, we have the conducting wires, shown as a single line. The switch, next, is off. Below is what it looks like when it's on. A light bulb is shown as a circle with a cross in it. And, finally, a voltmeter is a circle with a V in it. It is important to note that the voltmeter should always be connected in series as shown. The reason is that the voltmeter measures the electrical pressure across it and therefore gives a very high resistance. You will never get a correct reading if the meter is connected in parallel.